My name is Mary, and welcome to part 2 of this session on number bases. Earlier we learned about what number bases are. They are just the number or combination of digits that accounting system uses to represent numbers. We learned the use of base 2 in computers. We learned how human populations use base 10 because we have 10 fingers, and the fact that the Babylonians, long ago before the birth of Jesus, they used base 60. Can you imagine? Okay, so what we are going to do, we also learned how to convert a number from any base to base 10, and we also learned how to convert a number from base 10 to any other base. Next thing we are going to learn is how to deal with converting numbers that have decimal part, okay? And also how to convert between bases. We have already learned the core concepts, so we're just going to be building on that. Let's take this question that says convert 111 point, so it has a decimal part, 1101. It's in base 6, but this should be any base really. Base 6 to a number in base 10. Okay, so how we go about this? Basically, remember these numbers are below 0, right? They are a decimal part, right? The fractional part. If it's a whole, then it goes over to the whole number part. But so that's why we'll be having negative exponents on this side. So usually from before we said we'll label our powers or the exponents starting from 0, the next one is 1, and the other is 2. Now, moving on to this other end, we'll be having the first one as minus 1. So remember, this is tenths, right? So ones, tenths, hundreds. Here we have tenths, we have hundreds, thousandths with the THS. So this is going to be raised to the power minus 2, raised to the power minus 3, raised to the power minus 4. Okay? So that's really where the key thing is. So let's just take this number 111.1101 in base 6. And so that will be equal to, we expand as usual. So it's going to be 1 multiplied by the base, we're dealing with 6, raised to the power 2 in this case, because we're starting from the left coming in. So this is going to be 2. Let's close that to make our solution neat. And then we take the next number 1 again, multiplied by, same with the base 6, we'll raise it to the power, 1. Okay? So this will now be equal to, let's say, let me just use up this space. The next number is 1 multiplied by 6 raised to the power 0. Plus, we move to the fractional part now. This is going to be 1 multiplied by the base 6 all raised to the power minus 1. Plus 1 multiplied by 6 raised to the power minus 2. Plus 0 multiplied by 6 raised to the power minus 3. Okay? And then finally, plus 1 multiplied by the base 6 raised to the power minus 4. Okay? So what we are going to have now is, we're going to basically find the solutions for these exponents and multiply the terms out. So we're going to have all of this equal to 1, so 6 squared is going to be 36, right? So 1 times, anyway, let's do it step by step. 1 times 36 plus 1 times 6 raised to the power 1 is just 6. 1 times 6, anyway, 1 times 6. I'm trying to manage time here. Plus 1 times 6 raised to the power 0 is 1. So 1 times 1 plus 1 times 6 raised to the power minus 1. Now, the property of exponents is when we have a negative exponent, for example, a raised to the power minus 1, this is going to be equal to 1 over the positive, so this same value raised to the power 1, but positive 1. Keep this in mind, okay? If this is minus 2 here, this is now going to be plus 2, represented this way. So therefore we will have here, so this is going to be 1 multiplied by 1, just as we put here, raised to the power, divided by 6, but instead of raised to the power minus 1, I'm just going to be positive 1. We're often just going to put that even positive 1 because it's just 6, right? Okay. So next plus, move to the other term, 1 multiplied by 6 raised to the power minus 2, we do the same thing. We say 1 over, we write the same value 6, but now instead of the negative exponent, that exponent becomes positive. So 6 raised to the power 2, right? Plus, the next one, 0 multiplied by 6 raised to the power minus 3, we do the same 1 over the same value 6 for raised to the positive exponent. And then finally we have 1 multiplied by 6 raised to the power minus 4, we say 1 over 6 raised to the positive power 4. Okay? Now, let's move on to the next step. 1 times 36 is 36. Plus 1 times 6 is 6, plus 1 times 1 is 1, plus 1 times 1 raised to the power 6, so 1 divided by 6 raised to the power 1 is going to be 1, because 1 multiplied by 1, and then we just add the, we put the denominator. So 1 raised to the power, divided by 6. Next one, we have 1 times 1 over 6, which is raised to the power 2. 6 raised to the power 2 is 36, right? So this is going to be 1 times 1 over 6 squared is 36. Plus, this is going to be 0, because any number multiplied by 0 is going to just be 0. So let's just ignore that. So that's going to be 0. Although it would be good to find 6 cubed and that value, but it will be of no use for us in our solution. Actually, maybe just for good practice, let's teach you that. Where is my calculator? 6 cubed, 216. 216. With 0 multiplied by 1 over 216, which is going to be 0 anyhow, like I said. But next we have the last one, which is 6 raised to the power 4 is 1296. So this is going to be 1 multiplied by 1 is going to be 1 divided by 1296. Okay, so now let's add the whole number ones first. We have 36 plus 6 plus 1. We have 43. So this is 43. So this is all equal to 43 plus. Now we have 6, 36, 216, 1296. You will notice already that these are all factors of 6666, right? So what we'll do, let's take the LCM of these to be 1296, and we'll take each of these ones in turn. 6 into, so 1296 divided by 6 is going to be 216. Right? So how many times does 6 go into 1206? It's 216 times. 216 multiplied by 1, which is the numerator here, is going to be 216 plus 36. Again, how much it go? How many times does this go into 1296? We say 1296 divided by 36 is going to be 36, right? So 36 times 1 is going to be 36. Plus, we take we ignore this value because it's 0. 1296 goes into 1296 1 times 1 is just 1. So therefore we are going to have all of this summing. So let's just note it down. We have so this is all equal to 43 plus, let's add up these values here. 216 plus 36 plus 1 is 253. 253 divided by 1296. Okay. Now, to have this all as one number, we just remember 43 is the same as 43 over 1. So the LCM of this and this is just 1000. We multiply them, 1296. How many times does 1 come into 1296? It's 1296 times. 1296 times multiplied by the numerator there times 43 is going to be 55,728. Now don't be afraid of the numbers, take them step by step. And then of course plus, this is going to be 1296 comes into itself 1 times 253 is going to be 253. So this is going to be equal to this 55,728 plus 253 is going to be 55,981 divided by 1296. Now, let me try dividing that and see if we have a clean number. 1296. We have the value 43.195 as our answer. Okay, so therefore the value 111.1101 in base 6 is equal to 43.1. So really 43.2 to round this up, 43.2 in base 10. So the step is in dealing with those negative exponents. That's where often even with students I teach, that's where they have challenges. Okay, so that's we've dealt with that. Let's now look at converting between bases other than 10. We have a problem here that says convert 321 in base 4 to a number in base 7. Now, how we go about this? We will first convert this number to base 10, and now this number represented in base 10, that representation base 10 is what we will convert to base 7. Okay? So, step 1, we say convert 3214 to base 10. How we do that? You already know. 321 in base 4 is equal to, we label our powers 0, 1, 2. It's going to be equal to 3 multiplied by 4 raised to the power 2 plus 2 multiplied by our base 4 raised to the power 1 plus 1 multiplied by our base 4 raised to the power 0. This is all going to be equal to 3 multiplied by 4 raised to the power 2 is 4 times 4, 16, plus 4 raised to the power 1 is 4, so we have 2 times 4 plus 1 times 4 raised to the power 0 is 1. So this is going to be equal to 3 times 16. Sorry, I'm trying to raise with the time here. 48 plus 2 times 4, 8 plus 1 times 1, 1. So this is going to be equal to 48 plus 8 plus 1 is 57 in base 10. So this value here is 57 in base 10. Now this same value is now what we are going to convert to base 7. So we say step 2, convert result in step 1 to base 7. Right? Let's turn over. So we say that would be 57. We draw a table as we did before, converting that to base 7. Now, so we're dividing 2 by 7 because that's the base we're interested in. So, how many times does 7 go into 57? Now, your multiplication tables help here. So, 7 times 7 is 49, right? Yes, 7 times 7, 49. So, we have 7 sevens in 57. But then we also have another one, so it's 8 sevens. Right? So 7 times 8, 56, and then remainder 1. So we have 8 remainder 1. 7 again, we divide again by 7, 7 into 8 is 1 times remainder 1. We divide again by 7, 7 into 1, 0 times remainder will bring down the 1. And then we read our answer from the bottom up. We say, therefore, our value are 3, 2, 1 in base 4 is equal to, we read from the bottom, 1, 1, 1 in base 7 as our answer. Okay? So I hope you've got this now. Yeah, let me see, maybe we need to move on to the